My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
Hi everyone. Hi everyone. Who is here after yesterday's class? Anyone who remembers sorting, which we discussed yesterday? Am I audible? Can you hear me? Okay, let's just see whom I remember. I think. Okay. Okay. Let's just see. Yes, cool. FIFA. Clear. So can you quickly tell me what is bubble sort in couple of lines? We'll do searching programs today. So just wanted to revise this sorting thing. Step by step swap by comparing. Okay. Then, so what's the main theme about bubble sort? Anyone other than Afifa? Okay. How about selection sort? Selection sort. Who remembers what is selection sort? Nobody here remembers? Respond. Okay. Select number, then compare with the nearest number, then swap. Okay. Selection sort is selecting the minimum number and then swap with the first unsorted area. Okay. Do you think I should revise quickly now? Say yes or no. Because today we are just doing searching. Selection sort. Okay, let me just share the screen, complete screen, and then explain. Okay. Fine. So 14, 5, 16, 12, 2, 6, 18. Okay. Bubble sort. It's kind of a revision, guys. Bubble sort means what? What happens in bubble sort? Step one. So we compare each element, like adjacent elements, like 14 is compared with 5. Okay, so as 14 is bigger than 5, it is swapped. Next iteration it becomes 15, 5, 14, then remaining element. Okay, What happens next? 14 is compared with 16. Yes, 16 is greater, so we are not swapping. Okay, now 16 is compared with 12. 16 is greater than 12, so we are swapping it. So what happens then? The next iteration, 16 goes in this position, okay, and then 12 stays here. Then 16 is compared with 2. Yes, 2 comes here, 16 goes in this area. Then 16 is compared with 6. 6 and 16. 16 is compared with 18, but 18 is greater. So at first round or iteration, this is sorted part, and this is unsorted part. Clear? This is very simple bubble sort. Bubble sort means check out, keep comparing adjacent elements, and at the end of the first iteration, the largest element will be at the bottom. And again, in this iteration, it will be 16. Okay. In third iteration, it will be 14. So what will happen? 5, 12, 2, 6, 14, 16, 18. Okay. The next iteration again 5, 2, 6, 12. Then this is sorted part. Again, we are comparing everything, and we see that 6 is the largest. So that's not changed. 2 and 5. So 2 is swapped with 5. So bubble sort means the larger element will be sent at the end. Okay. Fine. I think the simple logic for bubble sort is compare the adjacent elements using two loops and make sure the largest element is moved to the last of it, last of unsorted part. Okay, that is bubble sort. Selection sort means what? A logic of selection sort. Select the smallest element in unsorted part and swap with the first part of unsorted part. Okay, there are two parts. One is sorted, unsorted. Let's just use the same thing. Okay, let's use the same thing and try selection sort. Cool. Okay, here what we do, we iterate through this, or we start checking out which is the smallest element. When we get to know 2 is the smallest element, we swap with the first unsorted part of this array. So at the initial stage, everything is unsorted according to the selection sort. So what we are doing, we are taking 2 and swapping with 14. So what happens at the end of first iteration, 2 comes here, 14 goes this place, and this part is sorted. So if you see left side, all the elements are smaller than the elements of right side. Okay, in the second iteration, I compare adjacent elements. I get the minimum among this and swap with the first element. So if you really see, 5 is the smallest element and I'm swapping with the same one. So the next iteration, the sorted part is 2 and 5. Okay. Next, in the third iteration, I check out which is the smallest element in this part, in the last 5 elements. So 6 is the smallest. So what we do in the next iteration, how it will be? So what we will do, 6 will be swapped with which number? Yes, that's amazing. So 2 and 16. Okay. Next, in the next one, which will be selected? 12, 14, 16. If you see, this is all already sorted and there won't be more swapping. This is selection sort. Selection sort means left part is sorted, right part, smallest part element is taken and sorted with the swapped with first element of unsorted part. Let's just take the same thing with insertion sort. Okay, what happens in insertion sort? Insertion sort, in the first iteration, what they do, they assume that first element is already sorted. Okay, so if you, when there is only one element, definitely that is a sorted part. Clear? Okay, so what they do in second iteration, they take 5. Insertion means they are going to insert at specified, like its right position. Okay, so what I'm doing, I'm taking 5 and I'm comparing with 14. So I see is 5 is smaller than 14. So what happens? 5 and 14 are swapped. So it comes here. And again, as there are no more elements, this is the sorted part in the next iteration. We take, copy this, go to next iteration. In the subsequent iteration, again, the first element is taken and compared with last element of sorted part. When we see that is already greater, so we are not going to swap, we'll just make sure the next iteration, this part becomes sorted. This is unsorted. Okay. Next, what happens after this? Here, when we come to this position, we are having 12. And what we do, we compare with 16. So what happens in the next iteration? Straight 12 and 16 are swapped. Okay. Again, 12 is compared with 14. Again, they are swapped. Okay. Then 12 is compared with 5. So we see that 5 is smaller. So 12 is the right position. And at this point, this array is sorted. This part is unsorted. Any doubt in this? In the insertion sort, insert the element in its right position. That's the insertion sort. Okay, clear? So what happens next? What will be the next position of this? Can you just quickly say iteration in this? What happens? So I compare 2 with 16 again. It goes till, what's the position of 2 at this point? Let's make it interactive. So insertion sort, selection sort is really interesting. Yeah, 2, 5, 12. Yes, this is the sorted part. Okay, next iteration. How many swapping happened here? How many swapping happened here? Dhanupriya, can you just tell me how many swapping happened here? In this? 4, clear. What about next one? What happens? So, as you told, so 2 comes here. This is sorted. So what for this 6? What's happening? Okay, 2, 5. That's great. A nice quick response. 2, 5, 6 is inserted at this position. Then again this. At the end, 18 is not swapped because it's in the right position. So after all the iteration, this is the right order of the element, the sorted order. This is insertion sort. Okay. Okay. Let's assume we want to do merge sort. So what do we do in merge sort? Cool. So what we do in merge sort is we take this, we divide in 2 parts. Imagine either this or this, anywhere. Okay. Part 1, part 2. Again, this is divided into 2 parts. Okay, when we go to the next level, like this. Okay, then again in the next level they are divided. So at this point we reach a stage where there is only one element in one part. Then what we do, we merge them. We compare 5 and 16. Yes, 5 is smaller than 16, we don't worry and we merge. So this part is sorted. We compare 12 and 2. No, they are not sorted. So 12 and 2 are swapped. Yes, this part is sorted, this part is sorted by merging. Then again, I come here. This is all good because 6 is smaller. Okay, so these 4 chunks are already sorted. Next, we have to compare these two parts and compare these two parts and combine. So 5 is compared with 14. Yes, 5 is smaller than it. It's kept first. Then 16 is compared with 14. 14 is smaller. The 14 is put into this position. Then 16. Then second part. 2 is compared with 6. 2 is smaller, so 2 is taken. Then 12 is compared with 6. 6 is smaller. 6 is taken. 12 is compared with 13. 12 is smaller. 12 is taken. Then at last 18. Okay. So at this point, we have two parts which are already sorted. Now we have to merge. Compare 5 with 2. When I compare 5 with 2, what happens here? Steps at least. Can anyone tell me the steps here? 5 is compared with 2. So which element I have to take here? 2 or 5? 2. Okay. Next. Should I compare 6 with 5? Yes. So when I compare, then I'll take 5. Then next, which number will be compared with 6? Which number? 14. So I see 6 is smaller than again 6. The same way, 12 is compared with 14. 12 is kept. 14 is compared with 18. 14. Right. Then 16. Then 18. This is merge sort. Okay. The logic is very simple here. Who are interested can. This is the only small logic. Two for loops for bubble sort, insertion also, for or while loop, whichever you want, you can use merge sort. I keep on dividing, then last I merge. This is called recursion, which we can check today. Then selection sort. Select the minimum, then swap. See here, at the end we are swapping with the minimum element. Okay. Okay. Anyone has particular questions on sorting? Any questions? Anything on sorting? Okay, just ping in the chat which all sorting algorithms you are aware of. Meanwhile, I'll have water. Everyone can respond. Which sorting algorithms do you know? Only 2, 3 people are responding. 4 people, I guess. Only 4. So there is no change. So you knew everything. Only these sorts. Okay. Quick sort. Okay. Do you know what is quick sort? Pratika? Okay. Anyone? There are so many sorting algorithms. Okay, great. Try to check these things. Can you open this and see how many sorting algorithms are there? Okay, let me see if anyone is aware of like having knowledge about more sorting algorithms in YouTube. No one is knowing. Is it's like there are more than 50 people. No other algorithms you are aware about? Counting sort, yes, that's really great. Okay. Any other thought? Just check out Google and make it interesting. Heap sort, yes, great. Heap sort we use. Selection sort, bubble sort, merge sort. These are the three things. Quick sort, Ashish. Okay, great. So there are so many sorts available. Okay, great. Bubble sort is the basic algorithm. Select small one. Okay, people are responding in more response there is there in the live YouTube than Zoom. Okay, that's really great to see. Now today we'll try to understand more on recursion as well as searching algorithm. Anyone is aware about recursion here? What is recursion? What do you mean by recursion? YouTube people? Function calling itself. Yes. Okay. Next. Anyone? Okay. Let's just try to see heap sort. Okay. No recursion. Calling function itself. Yes. Ashish is responding. Great. Thanks, Ashish. So recursion is just a concept where a function calls itself. Correct. In order to solve a particular program. But the components of recursion is it has two things. One is base case, second is recursive case. So recursion means a function calling itself. So there should be some point, right, where it has to stop calling. Correct? That's called base case. Okay? Correct? So let's just see key components of recursion. So base case, it's a scenario where function does not call itself. Prevents the function from calling itself by some criteria. Okay. Recursion means still the criteria is not met. We are modifying input and again calling it. Okay. So we are recursively dividing and doing it. Let's just see some example. Simple example of that. Okay. Okay. Look here. Hmm? Can anyone tell me what is factorial of 5? What is 5 factorial? 120. Okay, how are we not telling it? We are just saying like this, right? So it is like 5 star 4 star star 4 star, right? Okay, let me just type here. So recursion means what? Factorial means 5 factorial will be equal to 5 star 4 star 3 star 2 star 1. Correct? This is the one. Okay. So now in this, can you see every number, like number is decreased by 1 and the base case is here 1. So how it happens, how the program goes, let's just check it. Okay, so this is a program where I'm trying to find a factorial of number 5. Okay, so just see here. So what I'm doing, this function is called from this place at the beginning, and I'm checking if n equal to 0, return 1. Why? Because what is factorial of 0? 0 factorial is 1. Okay, correct? Right? Yes. 0 factorial is 1. So if the value passed here is 0, then return 1. Okay. If not, then what I should do? I should take a number and multiply the function by decreasing it. For example, let's just see here. If n is 5 and I call this function, factorial of 5 is called, it comes here. It sees n is not equal to 0. So at this point, n is 5. So what I should do, I am trying to return 5 into factorial of 5 minus 1, which will be 5 star of factorial of 4. Correct? 5 into whatever this function returns. Yes, this f4 is called. So when factorial 4 is called, what is n? N becomes 4. So for this function, for the next iteration, what happens? 4 star factorial of 3 is called. Okay, again, when factorial of 3 is called, it will be 3 star factorial of 2. When factorial of 2 is called, 2 star factorial of 1. But when n becomes 1, we can simply return, or I can write like this also, or I can use. Okay, I can return 1. Cool. So what happens? What factorial of 1 is returning? It is returning 1. Okay, then what is 2 star 1? What is factorial of 2? Will be 2 star 1, which will be 2. Now factorial of 3 will be returning 3 star 2, which will be 6. Factorial of 4 will be 4 star 6, which will be 24. And 24 5 will be 120. Clear? Who did not understand this? Factorial. Recursion. Who got this? Same simple question. Who did not get? Got it? Okay, great. Who did not get? Who did not understand? Who is here only for the attendance? Okay, if you got it, then I'll give you one example. Can you just write a code or logic which calculates 2 to the power of n, where n can be 2 to 100? Can you write this for YouTube people also? Write a program using recursion, or you can write pseudocode. I don't mind. Okay, I'll give you 5 minutes. Write the logic and give it to me. All of you. Who has written the answer here already? Someone wrote the answer. So where are we using this recursion for what purpose? Yes. Sometimes just check this factorial number. I'm calling the same function but decreasing n, right? If you see this, I'm just sharing the code in the chart. You see the code, okay? Here only, you can just see this. The factorial function is called but decreasing the number, which means we are reducing the problem to small one. Question again. Okay. Question is 2 to the power n. I'll just give you the question. Wait. Calculate the power of number 2. That's the question. Okay. If I ask you to calculate 2 to the power 4, you should give the answer. If I say 2 to the power 6 also, you should give answer. So basically, whatever number I give, 2 to the power that n, you should give me the answer using recursion. Can you write a program or pseudocode for it? Just take 5 minutes, I don't mind. The one which I'm sharing is recursion for factorial number. I'm watching YouTube also. In YouTube also people can give a pseudocode. Did you not understand the question? Like, see, if you don't practice or if you don't try, how will you understand? Every day I'm just coming and telling something. You people are not. I don't know even you people are trying or understanding because I have taken one Java program. Can someone write a pseudocode? No, no, Akshay, I'm asking about 2 to the power n. Pseudocode for 2 to the power n. This is what I have been telling. Use recursion to calculate the power of 2. Like 2 to the power 4, if I give, I should give 2 square means 4. 2 cube 8, 8. 2 raised to 4 is 16. Just give me a recursion or a pseudocode which finds 2 to the power n, like how n factorial I have given you the code, the same way. In the code, instead of n equal to 5, I can make it n equal to 10. The same way, if I give 2 to the power n, then you should give me the result. N can be anything from 2 to 100. Okay? Syed is responding in YouTube. Okay, go ahead. In 5 minutes I'll come. Just check out this. You Google, you give answer. I don't mind. Just try to find out. Write a recursive algorithm which finds 2 to the power n. Okay. see only one person responding. Okay. Okay, square root 2 square print square. If n equal to return true, else case n plus 2. Okay. Base equal to exponent 2 result 1. Okay, cool. Okay. So Hafifa, whatever you written recursion, it's the logic, but recursion is not like that. Cool. Okay. Let me just share you the screen. Okay. Now just check this. How this logic is working. Okay. Just check this. What we know, 2 to the power 0. What is the value of this? 2 raised to 0. Okay. People are responding. That's really great. Okay. 2 raised to 0 is 1. Okay. Okay. What about 2 raised to 1? What is the value of 2 raised to 1? 2 raised to 1 is 2. What about 2 raised to 2? 4. Then 2 raised to 3 is 8. So what happened? You just check this. In this, what we can see, we are always seeing the left part is common, right part every time we are multiplying by 2. Okay. 2 raised to 8, this is same as 2 raised to 2 into 2. Correct? What about 2 raised to 4, which is same as 2 raised to 1 into 2. Again here, 2 raised to 1 is same as 2 to the power of 0 star 2. Okay. So what will be 2 raised to n then? 2 raised to n will be equal to some number m. So which will be same as 2 to the power of n minus 1 star 2. Clear? So if you see here, this is logic is the same thing. So if I say 2 to the power of 3, so it goes to this method. When I see exponent as 0, I return 1. It means 2 raised to 0. If not, then what I'm doing? I'm doing 2 raised to n minus 1 into 2, which means 2 into, again calling a recursion with same base, but instead of 3, I am passing 2. Again the same way. So let's just debug and see this. Just check here. I put a debugger and I debug this. Okay. Okay, what is exponent now? 3. What is base? 2. So if exponent is 0, then only I am returning 1. Otherwise, I go to the else. So where I went to this place. Now base 2 into power 2 raised to n minus 1, which means 3 minus 1. At this point, it will be 2. So when I call this, see what is the exponent now? 2. Same way it goes on until unless I reach a position where exponent is 0. So when exponent becomes 0, it returns 1. Okay. And it came to this place. At this point, power of 2 raised to 0 is 1. 1 into base 2, which is 2. Again, it went back. 2 into 2, 4. So 4 into 2, which will be 8. The power of this is 8. See this? Anyone understood this? Okay. I got the answer, but logic, what is happening here? Every time I am decreasing the exponent. So what happens if I send here 6? What happens at the initial stage? 2 and 6 will come. And when it reaches here, this will be 2 star power of base 2 as well as 5, which will be decreased by 1. It goes here, again it will be decreased. The same way. So 2 will be multiplied by the number of times I want. Like 2 raised to 6 means 2 into 2 into up to 6 times. So that's when I'll get the result. Okay. Now we understood what's recursion and how we are using it. This is base case and this is a recursion which continues. So base case is the one which terminates the recursion. Okay. So 2 raised to 0 is the base case in this place. Understood? Who did not understand this? Recursion is one of the important interview question. Can someone tell me who did not understand this? Or at least who understood? Okay, whoever answered, can I give you one more small problem? Okay, yes, clear. I'll just give one small problem on recursion. Let me just check out which one will be easy for you. Can someone try this? Program to reverse a number using recursion. Can you try this? Write a program to reverse a number using recursion. Reversing number means the number is 1, 2, 3. Your output should be 3, 2, 1. Can you do this? This is mostly asked for all the freshers. Can someone try this? Anyone, just try it out. Anybody here? Use array, parse it, print it from last index. Okay. I'm just giving you a number. I'm not using array. It is not palindrome. Palindrome is something like this, actually. 1 to 1 is palindrome. I'm just asking you to reverse. You can write the code. Can someone try this logic? Yes, amazing. Can you quickly write a pseudocode for that? So 5 minutes we'll try this and then we'll start the searching algorithm. Someone try writing a program to reverse a number. Okay. Here Syed has given an answer. Yes, this is really great. Modulus of 10, then divide by 10, then add the number by 10. Yes, this is right, Syed. It's good. Okay. Okay, here also I'm getting the solutions from people. So let's just try to understand searching algorithms. Okay. So what are searching algorithms? What is binary search? Anyone has any idea on binary search? What is linear search? What is binary search? What is hashing? Mm-hmm. Okay. Yes, Mamta is saying when there's a two numbered. What do you mean by two numbered? It finds a question. Okay. What is the rules for binary search? Any idea what where we can apply binary search? What are the rules for it? Okay, we are going to find the mid. That's cool. Next. Okay. Binary search divide the whole elements into two halves. Is there a condition that it should be sorted? Yes, that's great. So for binary search, the array should be sorted. What about linear search? Great. Cool. That's amazing. If it is sorted, yeah, great. Okay, let's just say this. This diagram shows what is linear search. Linear search means we start from the zeroth index of an array and we keep on checking the subsequent indexes. Like, we'll imagine if I want to search 31, I'll check the number in the zeroth index. Like, I'll compare 31 with 10. No, it's not matching. I'll go to the next index. 51 with 31. No, it's not matching. I'll go to the next index. 31 with 2. No, it's not matching. Then again I'll go with the next index. So I keep on checking every index element. Then at one point, if I get that, then I'll break the loop. Then I'll say I find the element is found at index so and so. Okay. And above we are having a number which is present in the array. Below we don't have it. Okay. What would be the time complexity and space complexity for this? Okay, one person is saying O of n. What about others? Is there anyone with different answers? O of n. What about space complexity? Space complexity, Akshay? No, just about linear search. It's not about. Okay, O of 1. Correct. Great. How about binary search? What is the time complexity of binary search? N log n or log n? Okay. Ashish is responding here. Divide and conquer. Krishnaveni is okay. Great. Cool. So let's just spaces of n. Yes, correct. So many people know about search algorithm. Great. So which are the best search algorithms? Any other you know other than these two, linear and binary? See this. There are so many searches. Depth first search, breadth first, sequential search. Sequential search is same as linear search, right? Correct. Any other? Meta binary. What is meta binary? What is meta binary? Yeah, you can Google actually. I don't mind you googling and answering many, but what are they? What they do? That's majorly required, right? No one knows everything. Simple is why they are used. It's okay. It's okay to Google. No worries. So you learn. You need to understand and learn. Okay. Okay. Great. Let's just go. Considering that there are even non-CS background people are there. Linear search means what? It is a sequential search. It's a straightforward searching algorithm which checks or iterates through array and finds whether the target element is available or not. The input is either array or list or whatever, and the element which we have to search. What is the process? So we'll start from the first element, we'll iterate through it, compare the element with each element in the array. If the match is found, then we'll return the index, otherwise we'll return -1. That's the process. Cool. This is pseudocode. So for each element in an array, if element is equal to target, return the index, otherwise return -1. Generally, this pseudocode is something which in interviews asked. They may not ask you directly to code in any language. They'll ask, write a pseudocode, write a process, then you are asked to write the program using C or C++ or Java or JavaScript or Python, anything. Okay? No. As discussed, right? The best case is big of 1, worst case is O of n, average case is O of n, right? So space complexity again O of 1 because it is in place algorithm means we are not taking any new array. We are just using the same array and we are comparing. Cool. So let's just check the problem. Let's just see the problem. Okay. Let's see if someone can write it. Hey, this is the problem. Very straight. A for loop from 0 to length n minus 1. Check each element. Let's see this. I'll just show you debug, show this. Okay. Okay, at this point, what is I? I is 0. So in the array, 0th index, what is the value? 2. So I'm comparing 2 with the target. Target is 16. Fine, that's not true. So what I do? I go to the next iteration. Then again, I is 1 now. At first index, what is there? 8. So 8 is compared with 16. Again, that's not considered. Then again, I go to the next iteration. I is 2. At second index, what we have? 15. 15 is compared with target, which is 34, 16. And I keep on doing until I reach the target. So at the index 4, like 0, 1, 2, 3, 4. At fourth index, the target value matches. So what I do, I return that index. Correct? Then if the result is not equal to -1, it means, hey, we found the element in the array. Clear? Can someone try this in your own way? Your own, what do you call? I mean, any language which you are interested. Can you share me code snippet of C or C++ or Python, writing in your own different way? Okay, I'm interested to see the output. So I'll have some assignment. So I might find you, you know, I might ask you to search something like this. Find the the largest three distinct elements in an array. Who is responding? Anyone here want to try in different language rather than Java? Linear search, guys. Why? It's just an assignment kind of thing. This is something which people are interested. This is a interview question. Okay, no one is answering, at least in YouTube. Can I see someone writing a simple linear search algorithm? Okay, three largest element. Okay, that is cool. Third and okay. No, no, no. That is not the way. Like imagine this is array. I have to give you input. You should ask me whether I have given input or not. This is the input. Yes. Okay, I'm getting enter number of elements. Nice. I can see the answers. Good. Oh, you are using sort. Okay, that's great. Okay, here Python is also known. Great. Okay, do you have anything is needed for you to understand on linear search? Let me know. We can just reiterate this. It's simple. Compare element by element in a array. Then wherever you get the target element, return that index. Otherwise, return -1. Need doubts on that? Nothing? Okay. If there are no doubts, let's go to the next one, which is binary search. Okay. So binary search means generally the array is sorted. If you see here 15, 12, 22, 34, 36, 51, the numbers are sorted. So what we do, we take the middle element or middle index and then compare the target with the element at the middle index. If you see here, there are 7. So generally, third index is the middle one. 36 is compared with the target. If the number is equal to this, I'm going to return the index. Otherwise, if the number is smaller, I'm going to check in the left part. If the number is greater, I'm going to check in the right part. Right? Then again, I go to the next iteration. Now, if my number is 75, it should be greater than 36, right? Then what I do, I take these 3 elements. In this right part, 63 becomes mid, 51 becomes left, 75 becomes right. And again, I compare with mid. So 75 is not same as 63. Again, 63 is smaller, so I have to go to the right side. When I come to the right, there's only one element which is left, middle, and right, and compare that with the number. Then I get the result. This is a binary search. Anyone who has tried who has done the code of binary search? So basically, in a binary search, what we do, we divide the array in. Okay, no problem. So what we are doing, see, if this is the array, low low is 0, high will be array length -1. So what we are trying to do, we are trying to get the mid. Mid will be low plus high by 2, whatever, like high minus low I'm getting, which will be, if there are 6 elements, it will be either 3 or 4. If there are 7, then that will be middle one. Okay. So in this, if you see, there are 7 elements. This is the middle one. So this is the item which is compared, and then based on that, whether I have to search in the left part or right part, I'll decide based on the target. Okay. Imagine I'm asking to search 2. So when the code comes here, let's just debug and show you. Okay. So this method is called binary search. Array is having these elements, target is 2. Okay. Low is 0, high is 6. 6 plus 0 by 2, which is as good as 3. So 23 becomes, as the array starts from 0th index, 23 becomes middle element. Okay. Now mid is 3. And I'm trying to compare the element, or like the element in the middle of the array to the target element. So when I compare it, I see that 2 is not equal to 23. So what I'm doing next, if it's not equal, I'm trying to compare whether that is greater than target. So 23 is greater than target. No, it is not. Then I have to check in the left part. So that time what I'm going to do, I'm going to make 16, the index at 16 as the high. So now high becomes 2, low becomes 0. I mean, yes, number 2 index. Again, when I iterate, now the mid becomes 7, right? Because this part is truncated now. Now we want to only search in this area. Again, mid of this is 7. Yes, array of mid, which is 7. I'm comparing with target. Okay. No, 2 is not equal to this. Then again, array of mid is greater than target. Yes. So what I should do? I should make the high lesser than the mid. So which becomes 2 now. Now if you really see, low, high are same now. Both are 0. I compare array of mid. Mid is 0, target is 2, array of 2, 0 is 2. Right? So I'm returning this. So what happens? I get, say that element is found at index 0. Correct? Now, writing this logic is very difficult. You might feel, seeing this, you might say, oh no, nothing. We just need to divide and iterate in the left. If it is smaller, iterate in the right. If it is bigger, again divide, iterate left, right, or compare with the middle. But writing the code is always difficult. Okay. This is the logic for this. So what binary? One second, hold on. I think that is the binary search. Basically, we need sorted collections and the element which we want to search. So what's the procedure? We find the middle element of the collection, then compare that with target. If the middle element equals the target, the search is successful. Otherwise, we compare with the left part or right part. We see if the middle element is less than the target, then definitely the item will be left side. If it's greater, it will be right side. Okay. Divide in the same way. It's a divide and conquer kind of thing. Did you get this? Okay, I can get, like, there are a couple of people who have answered it. This is really good. But did you understand what is binary search? Okay, let's just try with simulation. You people also can try this. Okay, look here. If I want to do binary search, how it happens? The middle element is taken. Okay, so what we can write? Search for 47. Do a binary search. Every time middle element is considered, and then we say whether element is found or not. Let's try something with 470. Low and high are exchanged. .466 with binary search. Where the condition fails? Can anyone think of it? Linear search, just check one by one comparison. It keeps on comparing. Okay, let's just check with code. Okay, so just check the code. As long as while loop I have used, while low is lesser than or equal to high, which means if I'm making, if let's just say this, if this array, if I consider this as low, this has a high, and as long as high is in the right side, I can divide. So now let's just take this example. I'm trying to search 2. Okay, so where is mid now? Mid is here, correct? Now 23 I'm comparing with 2. Let's say target equal to, I'm comparing 23 with 2. No, 23 is bigger, so now high becomes, just check here, high becomes mid minus 1, so high will come here. Okay, in the second iteration, and now new mid will be low plus high minus low by 2, which will be 7. It will be here. Okay, again 7 is compared with 2, still greater than this, so high becomes 0th index, which will be this. Okay, in the next iteration, high plus low minus low by 2 means again this will be same as this, so everything will be in the 0th index. Okay, the only thing you people have to understand is when the binary search during this iteration or while loop, what are the values of high and low whenever I divide? Either if the value is lesser, then I decrease the high, means I make high mid minus 1. If the value is in the right part, I increase the low. I put the low in the next item. I mean, let's check this same thing. If I want to search something like 78, at the first 0th index is low, low will be 0, high will be 6. Yes, same thing. Akshay. Okay, so now the mid is this. See, if you see 23 is smaller than 78, which means now low will become mid plus 1. Now this will be the low. Now after the next iteration, mid will become here. Mid will be index 55. If you want, let's try that. 78. Okay, let's debug. Now low is 0, high is 6. Clear? So when I calculate the mid, it will be 3. At this point, I know it's greater than target. No, it's lesser. So now the new low should be next to mid. So which means I should search in the right part. In the second iteration, if the number is greater than the mid, then low will become mid plus 1. You see this? The number is lesser than high will become mid minus 1. That's the logic here. These are the only two logic. If the value in the mid is greater than the target, then we have to decrease the high. If the value is lesser than target, we have to increase the low. I mean, we have to put low equal to mid plus 1. Mid minus 1 will be high if the mid is greater than target, because we have to select the left part. Okay, you people can try this. Logic is simple. Compare the middle element. If the middle element is equal, then successful. Less, then high will become mid minus 1. Greater than low will become mid plus 1. That's it. Until unless low is greater than high. That's the base case. I mean, the case where it stops the loop. You can just check here. Check this logic. Is there anyone who cannot write this pseudocode? Any questions on this? Should we continue? Any questions on binary search? Collection. Just collection is a group of elements. That's it. Collection is as good as group of elements. It's an array basically. Okay. So time and space complexity, simple. Time complexity in the worst case is log n. Best case big of 1. Average is log n. Space is big of n because it's in place algorithm. We are not using any extra space. Okay. Now, last concept of today is hashing. So what is hashing? Hashing means, right? See, hashing and hash table are things which mostly people are asked. Okay, if you are going for Java interview or any normal interview, they'll ask how do you store the data using hashing. Okay, so imagine I have 7 buckets, 0 to 6. Okay, so what's happening? I'm telling, hey, put the numbers or put the balls or put the boxes in these buckets based on some algorithm. Okay, imagine, just check here. Imagine my input is 7. If my input is 7, I'll just use the hash function to calculate hash key. Based on the hash key, I'll keep that into the particular bucket. Okay. So imagine my input is 7. My hash function is that number mod of 7. 7 mod of 7 is what? 0. So I'm going to keep 7 into the 0th index. Yes, 7 is kept in 0th index. Next number is 16. What is 16 mod of 7? 2. So this will be kept in second index of the array. 33 mod is 5. It will be kept in 33. I mean fifth index. 42 will be kept in sixth index. So the hash keys are determined using this hash function. and the input values. With input values, hash function creates a hash key. Based on the hash key, the values kept in that index. Okay, this is a simple example. Hashing, yes, key value format, correct. Okay, so this is just a theory. It's the process of mapping a data of arbitrary size. Arbitrary size means something to fixed size. There will be value and key value will be there basically. So hash functions takes an input and provides a output using the hash code. That will be called as hash key or hash value. Okay, within that range only I'll get it, and based on that key I can put the value, but there will be collision. Okay, what is hash collision? Imagine there's an input called as 14. If I do 14 mod of 7, then definitely that hash case is 0. That time this index will become linked list, means in front of 7 the 14 is kept. If I get 32, or like what do you call 32, 32 is, yes, so 31, then definitely again I'll get 30. If I get 30 mod of 7 is 2. Again, collision will be there. Then I'll keep that in front of 16. Okay. That's what hash collision is all about. For example, if I get a number with the same hash key, if the hash function creates the hash key same for the number, but the number is different, then the collision will happen. At that time, I have to make that keep, or like just put it in the same key. Okay. Now, this is how it is done. Check this. So if I get something hash table, this is the example of hash table. Imagine I got 7. Key will be 0, value will be 7. If I got 14, key will be 0, value will be 14. Something like this. So here 12. In these 12 buckets, I'm just going to keep them based on the hash value I receive from the hash function. Okay. So what is hash table? It's a data structure which uses a hash function to map keys to indices, basically to this address. Imagine this is the address. So based on the key, it will map it. So insertion deletion is very fast because of the keys. Okay, either I can use array, or array will be there where data is stored, hash function to get the keys, collision resolution techniques will be there. So how can I remove the collision? Using the linked list. Okay. So there are some operation: insertion, deletion, retrieval. This is really key value based things. For collision, I can either do separate chaining or open addressing. These are the different methodologies. Load factor. So again, a lot of things. Rehashing happens if the link grows. Imagine there are 11, but I'm getting everything which is in with the index 0, means 7, 14, 21, 28, 35. Then definitely it will be in this same index. Then I have to rehash or do the change so that equally they are distributed. Okay. Yes, that is about today's class. Basically, we have revised sortings, bubble sort, which swaps like alternative elements. Then selection sort, select the smallest element and keep it sorted with the first element of unsorted part. Insertion sort, insert the element from unsorted part to the right position in the sorted part. Merge sort, divide until you get the response, and then merge at the end. Linear search, search element by element, and at one point you will find the result. Binary search is already is applied on the sorted array. Then divide the array into two half. If in the mid, if you find the element, you are successful. If not, the element is smaller, then search in the right side. If this element is bigger, search in the right side. If the element is smaller, search in the left side. Keep on doing it unless there are no more elements. Like low becomes greater than high. That's the logic. Hashing. Hashing means finding a way in which we can get the hash key and then we can store the data in buckets. Hashing is used in hash table. Clear? Okay, now it's time for queries. Any questions you want to ask? You can ask. What? No, no queries. Anything from? $42, yes. Hash key is single, but on a particular index, we will have a list. Akshay and Vinaya, just imagine this, okay? Though I might get same key, and same hash key, but the value differs. We keep on adding it to the link. Or in a binary search, what if the sequence is even? Sequence is even. How can we get the middle number? That's just like, see, if in a binary search, if there are six, either I take three or four. It's up to me. If you see the logic, then definitely you will be able to understand this. Just pasting the logic. Just check it out. This logic will give me, or I'll show you the answer. If you want, I can show what in the middle. Think you are showing int as chaining. Yes. No, hash collision for that. Yes, it's the solution for hash collision only. I'm right. You are right. But that's one of the way of storing the data, right? Because you have only seven buckets. Either adjust or like, if there are seven rooms, based on height, if you're arranging, then you will have some criteria, right? Okay, imagine there are five rooms. If you will be like saying that anyone from 5.1 to 6 feet go there, or like 5.1 to 5.5 go into one room, 5.6 to 5.10 go into other room, below 5 go into one room, below 7, above 7, if there is anyone go into other room, something like that, right? That's the criteria. Okay, anyone from the YouTube live chat, any queries on this? Okay. Thanks, Akshay. You have asked a lot of questions. Really great. I believe you are going to practice this and going to try more. Try the lead code problems or Mang or Fan, whatever. Anyone here? Any queries? Okay. If we are not having anything, I'll just tell you what we are going to do tomorrow. Tomorrow we are going to work on problems of dynamic programming. Okay. Dynamic programming, recursion, some problem solving strategies on dynamic programming. All those things we'll discuss tomorrow. Then day after tomorrow it will be trees and graphs. And then lastly, divide and conquer, greedy algorithm, backtracking algorithm. We're going to discuss all those things. Any queries? Anything? Okay, Ashish is asking me to explain the collision with example. Okay. I'll explain you. Wait. Okay, let's just assume there are only 4 buckets. Okay. Ashish, can you hear me? Okay. So, in the bucket one, let's just say this. Collision. Bucket 2, bucket 3, bucket 4. Okay. There are 4 buckets. So what I'll write a rule. There are the numbers are ranging from 0 to 100. Okay. I'll say any number between 0 to 24, put it in bucket B1. 25 to 49, the next bucket. 50 to 74, this bucket. 75 to 99, or like maybe 100 in this bucket. Okay. This is how the buckets are ordered. This is how the values are stored. So let's say I I always calculate this by 4, divide by 4. So I got number called as 21. 21 mod of 4 I'll do. 21 mod of 4 is 1. So I'll keep that number here. Okay, then I'll say 12 mod of 4. 12 mod of 4 is 0. Then 0 means I'll keep it here. Then next, what is next? Like 3 mod of 4. 3 mod of 4 is 3. And I'll keep it here. Okay. Till now there is no collision. Yes, Ashish? So what happens in case I got a number called as 8? 8 mod of 4 will lead to 0. So definitely the hash key of 12 and 8 are same. So I'm going to add only into this same bucket. That's how it is. So it's a space thing. Clear? I hope you understood that.
करा था मैंने कल करा था
Clear, guys? Hash collision. Oh, great. Thanks for the response, Ashish. Any other queries, folks? Those who are coming on for attendance also can ask. Let's hear it more from you. If no more queries, tomorrow will, as discussed, right? So remaining 3 days, backtracking, divide and conquer, dynamic programming, recursion, all these things. Okay? Graphs, BFS, DFS basics, how they work, all those things we can discuss. Cool. Okay, I'll be here for 5 more minutes. If you have any queries, paste in chat. Yes, Rupesh. You can ask your question. Gautam, our spoke will reach out to you. I'll reply you that. Okay, Amar. If there are no more queries, we'll continue tomorrow. Thank you all.
Yeah, sure. Thank you so much. So, guys, I have one more announcement actually regarding to the YouTube Live. So, from tomorrow onwards, we are not there on YouTube Live. So, you can join via Zoom. I'm sharing the link with you, and that link will be the same for remaining days. Okay.
Great. Thank you.
Okay, then. Thank you so much. We'll meet you on tomorrow.
Thank you all. Bye.
Yeah. Bye.